Welcome to Built, Wired, and Secured, the podcast where we explore how modern buildings are designed, connected, and protected in the real world. I'm Alex Morgan, and in today's episode, we're diving into patch or preserve, managing firmware, configuration drift, and updates in building systems, why it matters, where projects usually go wrong, and what decision makers need to understand before problems show up in production. Joining me today is Michael Harrington, a veteran of commercial property operations and risk management. Michael, glad to have you on.
Cold open. Imagine this. A routine overnight firmware push arrives for a bank of access control controllers. It's marked optional, installed on a handful of devices, and the vendor recommends the update. The next morning, several tenants can't badge into the building because door schedules are misapplied. The front desk is overwhelmed, and the property team scrambles for a rollback that doesn't exist. Tenants lose meetings, deliveries are delayed, and a single update turns into a half-day outage. That's the decision many teams face. Patch now and risk outage, or wait and expose systems to known vulnerabilities. Which path is more costly? Which is safer? That's what we'll unpack today.
Why do firmware and configuration updates in building systems matter in a different way than typical IT patching? In servers, we build testing pipelines. We can snapshot and revert, and we accept short reboots. In buildings, embedded controllers, HVAC sequences, access control, and life safety adjuncts tie directly to tenant experience and safety. A misapplied change doesn't just hit an application, it can lock people out, break schedules, or disturb climate systems across floors. Michael, from an operational standpoint, why are these differences so important to call out up front?
From an operational standpoint, there are three compact realities to keep in mind. First, many building devices are single-purpose and deeply embedded. They often lack the kind of transactional rollback or snapshot capability we take for granted in servers. Second, ownership is fragmented. Facilities, IT, integrators, and vendors all touch the same systems, but rarely share a single change process. And third, the downstream impact is immediate. Tenants feel this immediately. A server outage affects work for some users. A door or elevator that misbehaves affects the entire floor. So the risk profile is different, and policies that assume easy rollback or large maintenance windows just don't translate cleanly to buildings.
Let's dig into root causes. What typically leads to configuration drift and surprise updates in commercial properties? I hear terms like mixed vendor ecosystems and deferred inventories. Can you unpack the common failure modes?
Absolutely. There are several recurring causes we see. One is heterogeneous stacks. Different vendors, different update cadences, and incompatible assumptions about how upgrades are delivered. Two is unclear ownership. If nobody owns the firmware inventory, updates arrive and get applied ad hoc. Three is deferred hygiene. Teams let device firmware and config drift because the immediate day-to-day work seems more urgent, and over time the estate diverges from intended baselines. Four is vendor-driven pushes that present as recommended updates without context. Integrators sometimes apply these opportunistically. And five, perhaps less obvious, is parallel work streams. Trades doing construction, security, and IT changes simultaneously without a single change calendar. The result is a brittle setup where a single automated push can cascade failures across systems.
Those causes highlight the tension every property team faces. Security versus availability. Patching reduces exposure, but it can introduce outages. How should teams think about trade-offs and set policies that balance those priorities?
You have to make those trade-offs explicit and auditable. Start by categorizing risk. Which devices are safety critical, which are tenant impacting, and which are low impact. Apply a risk-based cadence. Critical security fixes for life safety adjuncts may justify immediate windows and coordinated rollback plans. Non-critical cosmetic patches can wait for scheduled change windows. Build policies around four practical controls. Change windows that align with tenant impact. An approval workflow that includes facilities and IT. A documented rollback plan for any change. And a mandatory communication template for tenants and frontline staff. Importantly, test the rollback. Don't assume it works on paper. Finally, except that some teams will choose to defer a patch until a full staging and validation can occur. That choice must be documented and reviewed, not ad hoc.
That makes sense. Talk to me about practical operational practices. What combination of lightweight controls gives the most risk reduction for the least operational overhead?
Start simple and repeatable. First, maintain a firmware and configuration inventory, device type, firmware version, last update date, and responsible owner. Second, adopt an immutable baseline approach for critical systems, a defined, documented configuration that you only change through a change request. Third, create a small staging environment, or use a staged rollout, where updates go to a subset of non-critical units first. Fourth, establish explicit change windows and a one-page rollback checklist that a technician can follow under pressure. Fifth, run regular tabletop exercises for common scenarios, lost access, HVAC schedule failures, or a bad rollback, so the team rehearses recovery steps. Sixth, bake these needs into capital planning. Fund spare controllers and spare time in project schedules so you're not forced into risky quick fixes. Real-life example. I once saw a building where a staged rollout caught a vendor firmware change that reset schedules. Because of the staging, only a handful of non-critical units were affected, and the vendor provided a patch within 24 hours. That's the payoff. Small operational discipline avoids large tenant impact.
You mentioned capital planning and spare hardware. Can you explain how that reduces vendor lock and outage risk without blowing up budgets?
Think of spares and staging as insurance that's inexpensive compared to tenant downtime. A modest investment in a couple of spare controllers or a small test bench that mirrors production lets you validate firmware behavior before rolling it out building-wide. When integrators or vendors push aggressive upgrade schedules, having your own ability to test reduces dependence on their timelines and gives negotiating leverage. You can say you'll accept updates on your terms, not theirs. Also, budget for periodic refreshes and for the labor to maintain baselines. Over time, that capital approach lowers the total cost of ownership because you avoid emergency patches, tenant credits, and reputational costs. It's a trade-off, but the numbers often favor modest upfront spending over repeated crisis responses.
We're approaching our wrap. Let's give listeners a compact takeaway checklist they can apply this week. Michael, what are the top 5 actions a property or IT leader should take tomorrow to reduce update risk?
Here are 5 practical steps. 1. Build or update a firmware/config inventory and assign clear owners. 2. Define critical versus non-critical devices and document your patch cadence for each tier. 3. Create an approval and communication process that includes facilities, IT, and tenant-facing teams. 4. Implement staged rollouts and a one-page rollback checklist for every change. 5. Schedule a quarterly tabletop exercise to rehearse common failure scenarios and validate assumptions. Do those 5 and you materially reduce surprise outages without needing major process overhauls. That's the pragmatic path forward.
Great. Thanks, Michael. For listeners who want templates, checklists, and the show notes from this episode, visit the Built, Wired, and Secured page at GDS Technology. You'll find the firmware inventory template, a sample rollback checklist, and a link to the tabletop exercise scenarios. That's the place to start if you want a ready-made kit to bring these ideas into your next operations meeting. That wraps up today's episode of Built, Wired, and Secured. We covered how firmware and configuration drift create brittle building operations, practical trade-offs between patching and uptime, and a compact checklist to reduce surprise failures. Thanks for spending time with us. And Michael, thanks for sharing these operational perspectives. Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world. Built to last, wired with intention, secured for the real world.